Try to understand nucleophiles and bases. It is a species rich in electron and has an unshared pair of electron available for bonding. In most of the cases, it is basic. What is the meaning of basic? That it is going to act as a base. It can abstract a proton. It may be negatively charged or neutral. Examples of nucleophiles are hydroxide ion, as you can see, OH with a negative charge, ethoxide ion, C2H5O with a negative charge. Similarly, chloride ion and amide, NH2 with a negative charge, HS negative, thiocyanate, bromide ion, ammonia. Now, ammonia and water are two examples of neutral nucleophiles. You can see NH3 is having a lone pair. It can donate its lone pair to make a bond. Similarly, water, it can also make a bond with its lone pair. Students, substrate and leaving groups are also two important terms that we are going to study in nucleophilic substitution reactions. An alkyl halide molecule on which the nucleophile is going to attack, it is called a substrate. Now this is an alkyl halide, as you can see, tertiary butyl group along with a chlorine atom. So overall this is alkyl halide. On this alkyl halide a nucleophile might attack. So an alkyl halide molecule on which a nucleophile will attack is called as a substrate. Let us try to understand what is a leaving group. Leaving group is also a nucleophile. As I have already told you that one nucleophile is going to replace another nucleophile. So the incoming group is also a nucleophile and the leaving group is also a nucleophile. It departs with an unshared pair of electron. As you can see, I have placed a complete headed arrow. Means this pair of electron will be taken up with chlorine and is going to depart as Cl negative. The incoming nucleophile must be stronger than the departing one. Only then it can make a bond and try to break this bond. So the incoming nucleophile must be stronger as compared to the leaving group. Chloride, bromide, iodide, bisulfate are good leaving groups, means that they can easily depart. Poor leaving groups are OH, OR, NH2. Why, students? Because they are going to make a strong bond. So if they are going to make a strong bond, then they will be poor leaving groups. Iodide ion is a good nucleophile as well as a good leaving group. Now students, in order to understand this concept, let us compare these two equations. First, we should write the chemical equation for the two processes. Consider this Ha as an acid. Now you know that an acid always donates its proton and it dissociates, giving ions H positive ion and A negative ion. Ka is the acid dissociation constant. Now consider this as an alkyl halide. Now you can see that the leaving group is going to depart, giving you two ions, a carbocation, and it can be any nucleophile containing a negative charge. Now these two equations represent Bronsted acid dissociation. As you can see, according to Bronsted concept, an acid is a species which is going to donate its proton. And the loss of a leaving group in SN1, you can see the similarity in these two chemical equations. Now students, both show heterolytic cleavage. You can see that A negative is departing with a negative charge over here by taking this pair of electron. Similarly, this leaving group is also taking along with it a pair of electron, giving us a cation and an anion in both of these reactions you can observe. Now students, we know that for acidity, a more stable A negative, then the more equilibrium will be favor for the dissociation, and release of proton, meaning Ha is more acidic, means more readily it donates its H positive ion, it is a good acid. And how readily this Ha bond is broken down depends upon the stability of this A negative, which is the conjugate base. Now students, for the leaving group, the more stable the leaving group is, it favors its leaving. Means only that leaving group is going to depart easily, which is going to be stabilized after it is going to depart. Means Lg, any nucleophile carrying a negative charge, if it is more stable after departure, then it is going to be a good leaving group. Hence, factors that stabilizes A negative also applies to the stabilization of the leaving group. So similar concepts apply on both of these reactions. Students, let us study some leaving groups. Here is a table classifying some common leaving groups that we will encounter. Excellent leaving groups are tosylate group and ammonia. Why they are excellent leaving groups? Because after the breakage of the bond and when they are going to depart, they are stabilized themselves. Even though they are going to carry a negative charge, but they are going to stabilize themselves. Now observe in tosylate group. After the departure, after it is acting as a leaving group, it is going to stabilize itself. How? Due to resonance. This negative charge is going to circulate in this whole system due to resonance. Negative charge will shift over here, this pi bond over here, and it is going to circulate in the whole ring. Therefore, this whole system will be stabilized. Always remember students that whatever leaving group is stable, it is going to be an excellent leaving group. But if the leaving group is highly unstable after its departure, for example OH negative, it is highly reactive and is not stable on its own. Therefore, it is a poor leaving group because once it is going to depart, it is not going to stabilize itself. It is very reactive. So, it cannot live on its own as OH negative. Therefore, it is a poor leaving group. Water itself is a good leaving group since it is a conjugate base of hydronium ion. Students, try to understand all these concepts, apply them and solve these questions.